Greetings! Today I have a package that came in mail today, straight from China, and I started opening it up, and then I stopped. I thought, let me do this on camera, because just by touching it I kinda knew what's inside, so that potentially can be interesting. So let's get to it. There we go. A little anti-static bag, and inside that's difficult to open. Inside there are supposedly 5 milliwatt laser modules. So I bought those just to see what 5 milliwatts can do, out of curiosity, and to compare them really with those. Those is something else I bought earlier on. So this is just a laser pointer. This the output of this is less than 1 milliwatt. Okay, what you see on here, there is a little lens that I've stuck on it, on the top of it, with a tiny bit of white tack, and this, when focused, will burn paper, will cut black electric tape and all the usual stuff that people do irresponsibly with overpowered lasers. This is 1 milliwatt. This is meant to be 5 milliwatt. We'll see that in a moment if that is the case. I'm just finding it hard to believe. However, looking at this closer, this construction is somewhat interesting. So those are 5 volt modules, so there isn't a constant current driver for the laser LED inside. There was a choice of 4.5 volts or 5 volt modules. I chose the 5 volt ones, and all there is to it is a resistor to limit the current, and that's it. There is a roughly cut section of copper PCB stuck in a little notch in the housing, I guess I could call it, and that's all there is to it. So let me power this up, get a power supply ready, and let's see if this really is 5 milliwatts. Okay, and I'm back. I've quickly tacked on one of the modules onto a power USB lead. I'm gonna plug this into a power supply, and I will be either very impressed or very disappointed, and I think it's gonna be the latter, but let's have a look. Okay, it works. I just can't see that being 5 milliwatts. I mean, if I compare this, I'll take the lens off. You can clearly see that the 1 milliwatt is significantly brighter. I mean, the center of the 1 milliwatt laser, this one, when I look it from the side on a piece of paper, the center of it is almost white. It's so bright. This one is just red, and it has also a lot more side projections, so it's really horrible quality. really. Let's see if I put a lens on it, the same one as on the other one, will it make any? No, that just doesn't want to do it. Let's have a look how much current does it take. Okay, so let's test what will be the current on this JAWS. I've got a multimeter set on microamps or milliamps. I've put the module in this contraption here so it doesn't fall over when I pull on the wire or anything and burn my eye with full 5 milliwatts. Let's plug this in and let's have a look. Okay, so it's too much in microamps, so it's 30 milliamps. 30 milliamps at 5 volts. Well, that would equate to about, let me get a calculator for this because I will get this wrong. So we've got 5 volts times 30 milliamps is 150 milliwatts. That's clearly not right. Well, some of the power must get dissipated in the resistor. Let's check what the resistor is. Okay, so I've measured the resistor on here on the diode, and that appears to be 90 ohm. We've measured the current, which was 30 milliamps. So the voltage drop on the resistor alone will be 30 milliamps times 90 ohm. That will be 2.7 volts. So that means the voltage drop on the diode itself is 2.3 volts, and this, so 2.3 times 30 milliamps, and I'll need a calculator for this. 2.3 times 0.03, that's 69 milliwatts. Or 0.069 watts. Okay, so that's the power that it's consuming, but clearly that much power is not coming out. So what I'll probably do, I could have just looked. It seems, because this resistor is all white, there is nothing on this, probably upside down. I've picked up another one and it says 910, so 91 ohms. Yeah, they're all 91 ohms. So I am tempted pull the insides from this. So there's two pieces of what looks like PCB material, and there is a metal sheet wedged in between, and all of that is wedged into the housing. So I will just pick one of those. Yeah, that sounds good. That looks good. And I'm going to pull this out to see what's there. Okay, that came out. And there's the diode. Oh, this is tiny. This is absolutely tiny. Let me just put a macro lens on this and I'll show you. Okay, so there we go. That's negative side of the whole construction. Excuse my shaky hand. This is quite a large zoom and I'm doing this freehand. So this goes to the resistor. The resistor goes across. There is one little via going across to the other side, and that goes to the other wire, which is here. Well, not to the other wire. After it goes through via, it makes contact with, let me just focus, with this plate, which is, that's wedged in between between two PCBs. So there's this it looks like copper-ish thing, a bit yellow, maybe brass. And on the other side of this, oh, I can't get this to focus now. Oh, there we go. And on this other side of this, you see the little brass sticking from underneath the copper clad. That is the actual laser diode. I mean, that thing is tiny. So small, it's difficult to see with naked eye. So I don't know, let's see if we can power this up without the lens and see what happens. Okay, there we go. I've got this powered up. Let me see if I can focus this. There we go. So that's what a naked laser diode looks like while powered up. There's a funny shape where the diode is, almost an outline of some sort of structure. So without the lens, this is the sort of shape that it makes. It's more of a line or oval shape. And then this lens inside here collimates the beam actually into just a dot, like we used to when we talk about laser. Now I'm really surprised how small this thing is, for one, and two, how it's made. I mean, I didn't exactly expect this. I thought there would be some sort of LED diode package inside, but this is clearly the cheapest possible version of a laser diode. Okay, and this fits straight back together, and if I got it straight, that should make a dot again. Let's see. Yeah, there we go. So that's what it is. So I'm not sure how to calculate the actual power of the diode, but what I think I will do, I will give it somewhat more power. So I will change that resistor to something slightly smaller, or rather I will solder another resistor in parallel with this one and see what will happen. So what I'm going to do is put another 91 ohm in there. So as a ballpark figure, that should give me about 45.5 ohms. So let's switch this off first. I'm just going to leave it on long legs. Don't care, I guess. It'll be easier to maneuver. Okay, that should do it. So now we should have roughly about twice the current. So let's see. Or this whole thing will just stop working. Okay, we've got 52 milliamps. Okay. Okay, it works still. So let's put another 90 ohms in line with that, should we? I suspect this module will be tested to destruction. I've left slightly longer legs on the previous resistor, so now it's easier to add more of them. So let's see what the current and the brightness will be now. This will be roughly about 30 ohms, if not less. Oops. No, that's much too much. Okay, I may have damaged the diode. So it changed, it's no longer the same. It's become much dimmer. It's showing 80 milliamps. Yeah, that's toasted. So it's giving a nice dot, but I think the current killed it. So now gives a tiny little dim dot, so it's not what it used to be. So yeah, is this 5 milliwatts? I doubt it. I mean, this, I can almost feel it warm on the hand, and that's 1 milliwatt. I doubt they would underrate the actual power rating. They are much likely to overrate it to attract a buyer. Now this has become really dim now. Okay, little laser modules. Disappointing, to be honest, but what would I expect? Just shorted the wires on the resistor for a split second and it just went off. So the current killed it completely. It's drawing 0 milliamps right now and it's toasted. And that's what you get. Tiny little module with a tiny diode, a resistor, and a collimating lens. There was a spring inside, I don't entirely understand why. Oh, I think the spring is holding the spring may be holding the lens in place. If I shine the other laser through the same lens, it just becomes widespread. It diffuses it quite a lot. Oh, that's something new. So the lens is pushed by the spring, but what I think they're doing, because the lens has got slightly, it's not just a round lens, it collimates the beam from basically what you saw, what was just a line, to something, to one point basically. So once they put it in, they will adjust the lens, maybe with like a suction cup or a piece of rubber, so you can press it in and then turn it around, maybe a little bit, a couple of degrees, until you get the focus perfect. So that's good to know. But other than that, slightly disappointing. But anyways, that's all I get from this for now, until I come up with better ways of doing something with this. So for the time being, take care.